All right. So I don't really know if there's a format, or maybe we'll just like develop some sort of format as we go. But for today, we're just going to talk about chapters 9.1 and 9.2 on sequences and series. So yeah, just going to recap everything that Tom had said in his videos and the content of the textbook. So a sequence is just an infinite list of numbers, and um, it's kind of like what we've seen like in the like previous like younger grades where we see like a list of numbers, and then we're trying to figure out what the pattern is from going from one number to the next number. So a sequence can be described in three ways. So Tom calls one of the ways directly, or in the textbook they call it numerically. So that's basically describing the value of the nth term of a sequence in terms of n. So the first term of a sequence, um, the first term of a sequence has a value, right? So we're trying to have an equation that expresses the value of that first term in terms of the fact that it's the first term. There's the example in the video. So like if you're going from like 1 to 2, then the second term is just the first term doubled. No, wait, actually, I got a little confused. So the second term would just be the value of the second term. If it were 2, then they would just be the fact that it's the nth term. Does that make sense? So I'll go over the other versions, and then that might clear it up a little bit. So numerically is describing the value of the nth term of a sequence in terms of the of n. And then there's another way that Tom called recursively, and I think the corresponding term in the textbook was called is called algebraically, and that's describing the value of the nth term of a sequence in terms of the previous term. So you're basically saying like his notation was Sn, right? So that's like whatever term you're talking about. So you'll talk about Sn in terms of S of n minus 1. And then the last way is graphically. So you just plot the nth term and its value as coordinates on a plane. Just a couple properties about of sequences, and one that's pretty common, and we kind of like talked about this idea before, and it's that sequences can converge or diverge. So converging would mean that as the sequence goes on, the numbers get closer and closer to a specific number, whereas diverge, it gets infinitely large or infinitely positive or infinitely negative. And so there is a kind of like a definition here. So for a sequence Sn, if the limit as n approaches infinity is a finite number, then the sequence Sn is considered to converge. A sequence is considered monotone if it only increases or decreases. And a sequence is bounded if there is an upper and lower limit to its values. So that's kind of like, if you could picture sort of like a sine or a cosine, like sort of like a oscillating wave looking relationship. So when something is bounded, it just means like all values lie within a certain range. Like you have like an upper limit and a lower limit. And there's a special situation where if a sequence is both monotone and bounded, that means that it converges. So you can think of it like this. You can think of it as like if all the values go towards one direction, but there's still a range, then that means that it's going towards a very specific value. And then that's it for sequences. I don't really know when we should ask the question. So if you guys at any point want to ask a question, just go ahead.
Yeah, I have a question.
Yeah.
So how does this correspond to integrals? Because it sounds like the same idea of like having boundaries and you're adding numbers. I'm not sure for a sum in particular. Are we getting our information from a graph? And if so, like how does that differ from using a integral instead?
I think this isn't. I think this is only very loosely connected to integral. It seems like we're sort of moving on.
But doesn't it seem like a similar idea though, of just like
Well,
boundaries and adding?
there are bounds, but we're not. But there's no like dx or like dy. There's no change in like in a certain
Sure,
like direction. So
sure, sure.
right now, it doesn't seem like there's that much of an overlap, but perhaps we'll like when we get more into it, then we'll see it. But so far, I don't see it.
hmm
Was there another part to your question?
Yeah, like the content that we receive to be able to produce a sequence function, is it
Um,
from a graph or is it from an equation
so
or
so sometimes he gives it as just like
is it like a
numbers, like
okay. Yeah.
separated by commas, but it can also be given as just a function.
Okay, yeah, yeah.
So and then what changes is the number, the 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 number in the sequence. So like which value in the sequence you're talking about, and that changes what the output is.
hmm
And then for 9.2, we're talking about series. And so series and sequences are very closely related. So a sequence is just an infinite list of numbers, and then a series is just the sum of an infinite list of numbers. So instead of writing it out, you just add them. You just add them all together. So just kind of like a sequence, a series can also converge or diverge. Um, if
Yeah, quick question.
Mhm.
Like, so can like a sequence be expressed graphically like a series, or will that not be very meaningful?
Can a sequence be expressed graphically like a series? Is that what you asked?
Yeah, like how you can plot like the points of a series on a graph, and you have like a linear, like exponential
Um,
graph.
it's a good question. I don't know if because then you're a so then what your like x-axis be like what the value of the series is after a certain number of terms, and then at the x as you have more terms, then the y value is different. Is that kind of what you're saying?
I mean,
I
I
feel
don't know.
like
I'm not
so
entirely sure.
for a series, it would just be a bunch of points on like a number line, right? Like if the series was just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it would just be those points on that number line, right? So it would be like a graph with it's just a function of x. There's no x and y. It's just x. Whereas if you're looking at a series, you could say, let's create a function f of x be equal to, the first n terms or the first x terms of a series, right? So that would be much easier to graph because you would have an x value and a corresponding y value that was produced by the sum of that series up to that term.
Mhm.
I don't know if that helps.
Yeah, that
I
makes
mean,
sense.
I can start to Google some examples that might be helpful, but like at a high level, yeah.
Okay. Um, so yeah, so a series is the sum of an infinite list of numbers, and if that sum is infinite, it means that the series is going to diverge, and then if the sum is finite, then that means it converges. So sort of like a macro picture, the goal for um, as Tom said, for like the coming weeks would be to determine if a series is finite or not. So there's a very specific kind of series that that seems like it's going to be important and it's called a geometric series, and it follows the form of it's of a plus ax plus ax squared plus ax to the third plus et cetera, where the power of the variable just keeps increasing. Um, so the idea is that we should think about how do we get from the first term to the second term. Um, so the indicator of whether of if a series is specifically a geometric series is when the rule to get from one to the next is to multiply by a fixed number. So he had a couple examples in this video, but we're not gonna go over that.